Hi, I'm Dylan, and I'm a rising junior at Beacon High School. Alright, this is my project. It doesn't have a name yet, but basically what it does is it translates physical contact on my hands to the lighting up of LEDs on my clothes. And that's really interesting to me because I'm like a kind of guy that, likes watching or likes doing physical activity, not just watching it. And a lot of that physical activity has to do with touching things with my hands. And I always thought it'd be cool if that contact could be represented somewhere more visible, like lights, I guess. I don't know. It's kind of flashy, but it's my thing. So this thing, it looks complicated, but it's really deceptively so. I think it's pretty simple. And here, let me show you why. So it's basically divided into two systems. One is the pressure sensor system, which you can see basically right here and some over here. We'll get to that. And then the LED system, which is this ribbon. First, the LED system, because that's it's a little simpler. The LED system is basically everything. Let's see if I can show you on this side of the breadboard. This side of the breadboard, right here. And to make it a little easier, all of the cables that connect to the Arduino are the red ones. So that's all you need to worry about for right now. We'll get to the others later. Alright, so the first cable, this red one with the sleeve, connects to the digital pin 10. And digital pin 10 is really important because it serves as a PWM pin. Now PWM means pulse wave modulation, and it allows a digital pin like D10 to simulate an analog output. And that's really important for me because I want to fade my lights in and out. I don't want it to just be on and off, and I think having an analog output would also be pretty cool in developing my skills as an Arduino user. All right, this other one, the one without the sleeve, connects to ground to make it a closed circuit. And this resistor right here, it's a 470 ohm resistor. All right, let's see. Yeah, all right, that about covers it for the LED system. All right, the touch sensor system. All right, this one's a little more complicated, so I'll have to go a little bit slower. All right, so every other color except for red is the pressure sensor, but I also color coded these to make it a little more simple. So the green ones are the ones that connect the pressure sensors to the breadboard. The yellow ones are the ones that connect the breadboard to the Arduino. That's it. Those are the only two colors for there. But it'll get a little more messy as we get into it. All right. So just as with any circuit, we need a power and a ground, and those two are represented here in this one. Yeah, and this one here. I also color coded these. These are the different brand than this one, and I think you can tell this one's a little duller, more gray. But anyway, the brighter ones are power and ground. This third one is the analog input, A0, and that is how I get the results of the readings from my pressure sensor to my Arduino, and that's pretty important. All right, let's see. Yeah. All right. Now we're gonna explain everything else. All right. First of all, this other resistor, it's a pull down resistor. It's a 10K resistor, and all right. I think that covers about everything except for the green wires and the pressure sensor. Yes. All right. So the pressure sensor, it's really interesting. It's a material called Velostat. And it basically works. It's a variable resistor, and it works by pressure. And so if I squeeze a sheet, right, it'll cause the resistance to go up. And I thought that was really cool, and I thought I had it all down, and I had basically connected it so it was like that, where it was like one sheet, and when I squeezed it, the readings would fluctuate, which was great because fluctuation is change, and change is good, especially when you're trying to do this stuff. But the other thing is that change is not good, and I noticed at its resting state, with nothing touching it, it would still fluctuate, and that's a huge problem because first, there are two options when I want to make it interact with the LEDs. I can either make it directly interact so that like a reading from this directly influences a reading from that, or I can make a kind of threshold so that that like above or below a certain point the LEDs do a certain thing. And that's what I was trying to do, but it's hard to establish a threshold when your readings are all over the place. So what my lead instructor Io showed me is that if I make it an open circuit, I can actually control how and when the readings fluctuate. So as you see right here, they're not touching each other, and so no current is flowing. And that's really important because if you know, that way my reading's always 0. It's nothing but 0. There's no fluctuation. There's no nothing. It's always 0. But when I squeeze them together, like say doing this, it will cause like that. So I squeeze them together, so they're apart and then they're together. Right? It'll cause the circuit to close, and it will cause a resistance to take place. And so on the serial plotter, a tool in Arduino, which basically makes a graph out of readings, you can see it like a flat line, and then it'll peak and then it'll come back down. And it's really cool because that way I can control how my LEDs act. Now sorry if you can't see them, but the LEDs are really dim. I'm hoping to fix that in a later thing. Yeah. But hopefully they can get a little brighter in the next video. Yeah. All right. So the code. All right. The code is really simple. There's not much to it. It's basically 3 lines. So there's an analog read function which takes the readings from the velostat, and then there's a storing. I store it inside a variable. I named the variable sensor val for what I think should be obvious reasons, and then I use that variable sensor val to regulate how the LEDs work. Anything else? Yes. My power source. This is really important. This is my power source. I've been using my computer as of yet, but this is like a really convenient little power cell that I've been using, and you know, thank you for watching. I think